Hello everyone. So I'm Dr. V. Bhuneshwari. So in this class, we are going to discuss about matrix multiplication. So to any two matrices A and B can be multiplied if and only if it satisfies the compatibility condition. So what do you mean by compatibility condition? Let me explain it to you now. Suppose that if we do have a matrix whose order is A by B and another matrix B whose order is C by D, then these two matrices can be multiplied together only when this B equals C. That is, the column of your first matrix should be equal to the row of your second matrix. Let me teach it with you an example. If suppose you do have a matrix A whose order is 2 by 3 and we do have another matrix B whose order is 3 by 1, then since the column of your first matrix is equal to the row of the second matrix, the matrix multiplication AB is possible. So this is our justifying condition. If it is not possible, then these two matrices cannot be multiplied together. Okay, and the resultant matrix will be of order of the remaining values. That is, your resultant matrix will be a matrix whose order is 2 by 1 for this case. Okay, so another thing you need to keep in your mind is the matrix BA is not equal to matrix AB. So similarly, when you observe here, B, let me consider the same example. B is a matrix whose order is 3 by 1 and A is another matrix whose order is 2 by 3. So since this 1 not equal to 2, the matrix multiplication BA is not possible. So we can conclude itself. So this kind of question can be asked in 1 mark, whether the matrix can be multiplied or not, like that. So let me teach you an example. Consider a matrix whose entries are 1, 2, minus 1, 2, 0, 1. B is 3, 3, 1, 0, minus 1, minus 2, 3. So we need to multiply these two matrices. First, let us check, consider the compatibility condition is getting satisfied or not. So this is a matrix whose order is 2 by 3. This is a matrix whose order is 3 by 2. Since the column of first matrix equals the row of second matrix, the matrix multiplication is possible for this case. So to multiply any matrix, you need to keep in your mind the number 7. That is, we need to first consider the rows of your first matrix followed by columns of your second matrix. So I need to multiply here A with B. 1, 2, minus 1, 2, 0, 1, and this need to be multiplied with B. So for B we have 3, 1, 0, minus 1, minus 2 and 3. As I told you, now you need to keep in your mind the number 7. So first let me consider the row of your first matrix. So the first row is nothing but we do have here 1, 2, minus 1 and this need to be multiplied with 3, 0, minus 2. Similarly, the first row need to be multiplied with all the columns of your second matrix. So here the first row is 1, 2, minus 1. So this need to be multiplied with the second column. So of the second matrix, it is minus 1, minus 1, 3. Similarly, here, since all the columns of your second matrix is over, then we need to move to our second row of the first matrix. So 2, 0, 1. Now this 2, 0, 1 need to be multiplied with the first row, that is 3, 0, minus 2. Similarly, here 2, 0, 1 need to be multiplied with the second row, that is 1, minus 1, 3. Now we need to do term by term multiplication for the values here. Okay. So 1 need to be multiplied with 3. So we do have 3 here. Put a plus sign. 2 need to be multiplied with 0. So 2 into 0 is 0. Put a plus sign. Minus 1 need to be multiplied with minus 2. So minus 1 into minus into minus is plus. 1 into 2 is 2 here. So here, similarly, term by term multiplication. 1 need to be multiplied with 1. It is 1. Let me put a default plus sign. 2 need to be multiplied with minus 1. So we do have minus 1, minus 2, plus minus 1 need to be multiplied with 3. So we do have minus 3 here. Similarly here, 2 into 3 is 6, plus 0 into 0 is 0, plus 1 into minus 2 is minus 2. Here, 2 into 1 is 2, plus 0 into minus 1 is 0, plus 1 into 3 is 3. So, we need to write our resultant answer. 3 plus 0 is 3, 3 plus 2 is 5. Here, we do have 1 plus into minus is minus 2, plus into minus is minus 3. So, negative need to be added together. 1 minus 5 is nothing but minus 4. So, if you have a doubt in this, you can make use of your calculator to calculate all these things. So here 6 plus 0 is 6 and 6 plus into minus is minus 6 minus 2 is nothing but 4. Here we do have 2 plus 3 is 5. So when you observe here, this is your resultant whose order is 2 by 2. That is what I have told you with an example 2 by 2. This should be the resultant order of matrix. Another example, a 2 by 2 matrix. Okay, so here the compatibility condition is obviously get satisfied for any square matrix. Here it is 2 by 2, here it is 2 by 2. So here both the BA, AB both are possible. So we need to multiply the two matrix AB 3, 4, 2, 1. This need to be multiplied with 1, 5, 2, 7. Okay. Consider the first row of your first matrix. It is nothing but a 3, 4, and this need to be multiplied with the first column of your second matrix. Similarly, consider the same first row and multiplied with the second column. Since it is over, we need to switch on to the second row of the first matrix. 2, 1 need to be multiplied with 1, 2. And similarly, 2, 1 need to be multiplied with the second column, which is nothing but 5, 7. Now we need to do with term by term multiplication. 7 number need to keep in your mind for matrix multiplication. Okay. So 3 ones are, just a minute. Yeah. 3 into 1 is 3 plus 4 twos are 8. Here we do have 3 into 5 is 15 plus 7 fours are 28. Similarly, 2 into 1 is 2. 2 into 1 is 2 again. 5 into 2 is 10 plus 7. So the resultant will be 8 plus 3 is 11, 28 plus 15. 8 plus 5 is 13, 3 balance 1. We do have 43, 4 and 17. Similarly, when you observe, the resultant matrix order will be 2 by 2. So if you have any queries, kindly do comment me. Thank you.